Okay, we're taking a look at Chapter 2, Section 4, and determining whether or not there appears to be a linear correlation between two variables by comparing the correlation coefficient R to the critical value of R. And I have exercises 9 through 12 set up here. And what they provide us is the value for R. What we need to do in order to make a determination is we will need the critical value, and to get the critical value we need to know how many pairs of data there are. So in question 9 here, they say go back to exercise 5. So that's over here. We've got 1, 2, 3, 4. We have 5 pairs of data, so we can go down to our table. They gave us this table within Chapter 2, Section 4. Generically, we will use Table A6, which has a lot more information on it. The column that they're giving you there is the column for alpha equals 0.05, which is the one that we will use. So with 5 pairs of data, 0.878 is the critical value. And what this means is the value of R, without regard to sign, needs to be at least this large, greater than or equal to this number, for us to consider these two variables as being linearly correlated. So is 0.127 greater than 0.878? It is not. And if it's not greater than the critical value, then we cannot conclude that the variables are linearly correlated. In example 10, they want us to go back to exercise 6. 1, 2, 3, 4, 5, 6, 7. So that's 0.754. So with 7 pairs of data, our critical value is 0.754. Is 0.980 greater than or equal to 0.754? It is. And because it is, we can conclude that the variables are linearly correlated. For question 11, they say go back to exercise 7. 1, 2, 3, 4, 5, 6, 7. So again, 7 pairs of data. Critical value is 0.754. And here our correlation is negative, but that's just the direction of the relationship. The number part is what talks about the strength. So is 0.987 greater than 0.754? It is. So we can conclude that the variables are linearly correlated. And in our last exercise, number 12, it says go back to 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pairs of data. And with 10 pairs of data, our minimum value for the correlation is 0.632. 0.017 is not greater than that value, so we cannot conclude that those variables are linearly correlated. So in terms of making the decision with R versus the correlation, that is the process that we will run through. Obviously, one of the things that we would like to see first is the scatter plot of the data, which is actually why questions 5, 6, 7, 8 come in the order that they do, where they're asking you to, back here, look at the scatter plot, and then after looking at the scatter plot, they want us to visit looking at what the critical value is versus the correlation coefficient. So we'd like to see linearity in the picture, and then once we see that, or that's reasonable, then we can come over here, make this comparison, and stand behind the results we